Hey guys, so we're given another problem here which states if m of xy dx is equal to n of xy dy is a homogeneous equation, prove that if it is expressed in terms of the polar coordinates r and theta by means of the substitution x equals r cosine theta and y is equal to r sine theta, it becomes separable. So our equation looks like this. After we substitute the values of x and y for the above equation, we got m of r cosine theta r sine theta equals n of r cosine theta r sine theta. And thus, if we differentiate x and y, we have dx is equal to negative r sine theta d theta plus cosine theta dr, and dy is equal to r cosine theta d theta plus sine theta dr. So we have applied here the chain rule for differentiation. Next is we have written the equation in this form: m of r cosine theta r sine theta, which is just equal to m of xy, is equal to negative r sine theta d theta plus cosine theta dr, and that whole expression is equal to n r cosine theta r sine theta r cosine theta d theta plus sine theta dr. So we could ignore the two expressions here, and we are left with m of negative r sine theta d theta plus cosine theta dr equals n times r cosine theta d theta plus sine theta dr. And after distribution, we got negative m r sine theta d theta plus m cosine theta dr equals r n cosine theta d theta plus n sine theta dr. And then, since we are going to prove here that this is a separable equation, we are going to try to separate all the expressions with the thetas on one side and all expressions with the r's on the other side. So we have done that here. We have m cosine theta dr minus n sine theta dr equals rn cosine theta d theta plus rm sine theta d theta. Further manipulation will give us this equation: dr over r is equal to n cosine theta plus m sine theta all over m cosine theta minus n sine theta d theta. And this is a separable equation, so we have answered, or we have proven the given situation. Thank you.